So today, finally, we get to learn about radian measure. Okay, radian measure is nothing but it's another unit that we measured angle, right? So we are already used to use degree system to measure the size of any angle. But now we will use radian measures to measure the angle, okay? And it's just nothing but, I mean, there's a lot of different unit system. Like for example, American uses inches and feet and yard and all, but most of the other countries in the world, it's just metric system. I mean, it's the same object in the same distance or same length or width and depth and weight and mass or whatever, but it's just different system to measure it. So there's a conversion. So just expect to have conversion problems between degrees and radians. And since we are learning radians and probably throughout this unit, and we will heavily focus more on radians because that's the new concept that we use. But when you have any practice problems or test problems, and then it should be clear which measure system that you are supposed to use. So it's gonna say clearly you have to provide your answer in radians or degrees, and the given answer choices will be accordingly prepared, okay? All right. Okay, so we see the circle centered at the origin over that quadrant again. Then here we will see how they came up with the idea of radians on this circle over the quadrant space. For this circle, as you clearly see, that we can measure from the center in any part of the outer circle point, and then we can measure as that's as like radians. So the letter R presents the radius here, right? Then from the standard position of the angle start, the initial side, and if you measure whatever the radius, and then through that outline of the circle, and you go through exactly same length. As you see, the radius is this length, and from the standard position and initial point, and along the circle outline, and you measure exactly same length, and then you stop, and then you get to put the terminal side at the end of that, right? Then we measure the angle. Then it's about 57.3 degrees, but this is how we define the 1 radian. Again, so whatever the size of the circle, whose center is at the origin of the quadrant, and you measure the radius, and then from the standard position of initial point of that angle measure, and then along the circle line, outline, and then you go a standard position in the positive way, and then you measure the exactly same length going over the curve of the circle, and then that's where the terminal side of the angle stops. Then if you measure it in degree, and then it's about 57.3, and then that's the definition of 1 radian. Okay, any questions so far? Okay, so this is just simply how we define the radians, right? Okay, so then, as you remember from your geo class, the circumference of that given circle is 2 pi r, which is the radius, right? Then with this matter, in this case, we can have the circumference So from the initial point all the way one circular motion, the length, the circumference will be 2 pi, the the radius, right? And then also, if you see circumference as the length of these particles that it measures by 1 radian by 1 radian, then that's also 2 pi radians. What I mean is the circumference based on the formula, and we can say 2 pi all the radii, right? 2 times pi times radii, right? And then since we define radians is this length will be the same as this length. And then if we have one more, and then that's also making the exactly same circumference covered, right? Then we can compare from 0, right? From 0 to 180 as pi. How is that? Because for one circular motion is 360. And that's gonna be all the way to the same starting point is measured as 2 pi. Then we can have the conclusion just pi radian is 180. So now from 0 all the way to 180 position as an angle in degree, and then it's gonna be pi. From this, right, comparison, now this is the key. So since all the way to one circular motion is 360 degree, and then that's gonna be 2 pi, right? If we just have the radian as 1, right? And then it's 2 pi. Then with that, 180, which is the half of the 360, will be equivalent to in radians as pi, because half of the 2 pi is pi. Okay, are we all good? Okay, then with this point, and then we can go further with, then if this is 0, and then this is pi, and then all the way to the original starting point, and then it's also 2 pi in radian, right? Then where it used to be 90, it's gonna be pi over 2. How do we know? Because it's from 0 to pi, it's in the middle. So it's exactly the half in 2 pieces, the half pieces, right? Then what could be the equivalent to 270? Now I have pi over 2, and then one more piece of pi over 2, and one more piece of pi over 2 there. Then how many pieces of pi over 2 do I have total so far until I hit 270? 1, 2, 3. So it's going to be 3 of pi over 2. That means 3 times pi over 2. And then this is what? 3 pi over 2. So that's 3 pi over 2. Then one more, right? Then it makes sense because from 3 pi over 2, how many pi over 2 did I go further until I hit the original starting point? 1 piece of pi over 2. This is 4 pi over 2, right? Same denominator, you just go ahead and add the denominator. It's a 3 pi plus pi, 4 pi, and then it's 2 pi. And algebraically it makes sense as well. Either way, all other ways will make sense to go around this. So where all this started from, the main principle is this. Pi radian is 180. Then the key for radian measure is all around the circle whose center is at the origin. We will see all these radian measures as the segment of that circle pieces. So it's all about the pizza pieces all over that circle. So it's gonna be all fractional, right? Okay, any questions so far? Yeah, are we making sense? That's great, okay. All right, so now we came back to unicircle. So earlier, the circle that we were using is just random circle that we didn't really specifically define the length of radius. But if we talk about unicircle, everything is the same, but only difference is unicircle has specific radius that measures in 1 unit, right? So over the unicircle, if we explore the radian measures, then now still this is 0, and then measured 180 from there, and then this will be labeled with pi, right? Okay, then imagine that you have all these even fractional pieces all over the unicircle, but let's observe how many pieces were evenly divided here. 1, 2, 3, 4, 5, 6 up to pi. So that means one piece of this pizza has to be expressed by a fraction. The pi was divided evenly. How many pieces? 6 pieces. From 0 to 180, which is pi measure in radian. And we evenly divided 1, 2, 3, 4, 5, 6. So the one piece measure has to be in radian, pi divided by even 6 pieces. So the angle here, if we imagine the inscribed right triangle inside of that piece, then the angle in measure, the radian measure will be pi over 6. It's one piece of pi over 6. Then what if I go into the next, so this is pi over 6 here, right? Then if I have one more piece, then that means we have 2 pieces of pi over 6, right? Then it could measure with pi over 3. But why all of a sudden pi over 3? Pi over 3 was measured like this. We have 2 times of pi over 6. 1, 2, right? Then this is 2 pi over 6. And if I simplify, pi over 3. Then we can go further. One more, right? So then this must be 3 pieces of pi over 6. And if you simplify it, and that's nothing but pi over 2. And we remember we already came up with the position of pi over 2 as the half of pi measure. So that's why pi divided by 2, which is pi over 2. And then it makes sense in different aspects that we go by pi over 6 pieces. So if you get the hang of it already, then we can go all the way. So we can go one more piece, and then it's gonna be 4 pieces of pi over 6 even pieces. And that's gonna be 2 pi over 3. You notice that it's gonna be simplified from 4 pi over 6 as a 2 pi over 3, right? And then we can go further. One more, so that means we have a total of 5 pieces of pi over 6, and then it's literally 5 pi over 6 because it's already simplified in the simplest form. And one more, then that means we have total 6 pieces of pi over 6, and then it could be simplified 6, this is a 6 pieces of pi over 6, and then it's simplified to be pi, and we can go further. So one more will be 7 pi over 6, and this is 8 pi over 6 being reduced by 4 pi over 3. Then this is nothing but 9 pi over 6 and simplified to be 3 pi over 2. And also we already saw this was 270 position, and we can have 3 pi over 2 and in another way in previous slides as well. Then we can go further with 5 pi over 3 was 10 pi over 6. This is 11 pi over 6. And then this is 12 pi over 6 again, and then it's reduced to be 2 pi. That's all. Okay, then now if you remember from the lecture, the instruction that we had before spring break, and we were using 2 different kinds of special right triangle. So the ratio of the special right triangle 30, 60, 90, and the second kind was 45, 45, 90, right? So then this slide shows how we can divide all over the unit circle by pi over 6 piece, right? The 30 degrees. So in that case, this must be 30-degree equivalent in degrees. And in radian, it goes by pi over 6, right? Then, of course, we're gonna see how it goes by the other special right triangle, which is the isosceles 45, 45, 90, right? Okay, so let's see the next slides here. So if we divide this unit circle situation on a quadrant into all even pieces as 1, 2, 3, 4 even pieces from 0 to pi. Then the first piece we'll measure is pi over 4, 1 piece of pi over 4, because it's 4 even pieces from 0 to pi position. Then we can label the terminal side position as a pi over 4 in radian. Then what could be the degree equivalent here? Yeah, 45 degree, right? Then if we have one more, then that's 2 pieces of pi over 4, and you reduce it, and then it's also pi over 2. It should make the same measure pi over 2 as well. Then if we have one more, And then it's 3 pieces of pi over 4. It's literally 3 pi over 4. And we go one more. So then it's going to eventually make pi. And then it's also 4 pieces of pi over 4. And you reduce it. And then it's pi. And we can go all the way. So 5 pi over 4. And it's a 6 pi over 4, but reduced to 3 pi over 2 again. And 7 pieces of pi over 4. And 8 pieces pi over 4. 8 pieces of pi over 4 is equivalent to 2 pi again. So radian measure is, it has its own benefits. So you can see all these fractions over the unit circle, and then it's faster and easier for you guys to recognize what fraction over 2 pi or what fraction of pi can be measured as a radian angle, right? So the key is you have to see the angle as pieces, the pizza pieces inside of the circle from now on, okay? So then, since we already explore all one circular motion by pieces, and we can see all together at the same time here. So now if we project pi over 6 division and pi over 4 division all together, and we will have the angle position, angle terminal side position all over the unit circle like this. From 0, it goes pi over 6, and then pi over 3, but we can also include how pi over 4 is in between those two positions. And then we have pi over 2, and we go 2 pi over 3 and 5 pi over 6. And in between, we also have 3 pi over 4. And then now this is pi position, and we can just go all the way here. So now, the terminal side happens to be the axis, right? So the quadrant angle, which is 0, 2 pi, pi over 2, pi, 3 pi over 2, and 2 pi, the quadrant angle, and each quadrant, we will have this position, or 3 positions in each quadrant. So all these points are very, very crucial. So I need you guys to practice on blank paper, and you can construct in your own time, in your own practice. You can construct all over this crucial points on the unit circle then by yourself, right? So that you can get familiar to the positions and angle measures. And if you remember all this by your heart, and it's going to be a lot more convenient and faster for reasoning the further, deeper questions within this unit, okay? So then also, you can see all these positions, not only radian measures, but also degree measures as well. So it's still same position, but we can also see the 30, 45, 60, 90, and then 180 and 270 and 360, right? Okay. Then not only these certain crucial points all over the circle, and we should be able to convert from one system to the other, right? So now we can do any angle, not only those standard positions, the crucial points on the circle, and we can convert from any degrees to radians and any radians to degree, right? So the key is we know pi is equivalent to 180 degrees. And 180 degrees is equivalent to pi, 1 pi radian, right? Then if we have a special fraction that has pi on the numerator side and 180 in the denominator side, and this is technically 1. This is 1. As you experience through your whole math classes, right, then we always utilize this fraction that it has the same value, numerator and denominator, and it's just 1. And then we've been using this manipulation a lot, right? So we are going to use that fact, the conversion between degrees and radians too. So if we are supposed to convert any degree measure to radian measure, the example will go like this. So if you are given 25 degree, in order to convert it to radian, the multiplier that we need is pi on top and degree measure on the bottom. Why is this? Because our goal is we get rid of the degree unit so that we can have radian measure at the end. So the cancellation will go in here. The given degree will simplify or cancel with the denominator measure with the degree, right? Then all you have to do is you just simplify it at the end, and then this is the equivalent degree measure. Any question? Does it make sense? Okay. A lot of practice problem on 8.3 is this conversion, okay? So then what do we do to convert radians into degrees? The only difference is instead of pi over 180, because we will convert the radian measure into degrees, so the multiplier fraction that we need here is just upside down. So only difference is this. So we will use 180 over pi as the conversion multiplier from radians to degree. So if you are supposed to convert 5 pi over 18 radian measure into the degree, the multiplier that you need is 180 on top and pi on the bottom. If it's confusing or you just don't know which one to go with, and you always remember. So now, what is the goal? I'm converting this radian measure into degree, but degree doesn't really come with the pi notation. Then, in order to cancel pi, I have to have pi on the bottom. Then that forces you to have 180, the equivalent 180 degree on the top. And then you will remember that, right? So then to cancel, and then the 18 will simplify 180 as a 10, then 5 times 10 is 50 degree. Simple, right? So I uploaded this note on the additional material pages already. So I'm not gonna do all this example, the additional example during this instruction, but if you guys want more, excuse me, example, and then you can click this more example, and then there's like a 5 more example for you guys to do. And then it comes with this step-by-step and answer as well. So you can just click it, and then it's gonna lead you to the next slides, link to it, and then you can just try those problems too, okay? Then we can conclude today's by looking at next slide. So Next slide comes with comprehensive knowledge so far that we had here, okay? So list this quadrant angle, 0 or 2 pi, pi over 2, and pi, and 3 pi over 2, right? And you need to know the radian measures and degree measures, right? Then not only the quadrant angle, each quadrant we have this crucial 3 points there, right? Then all radian measures and equivalent degree measures, right? Then we already know how to get the exact values of all points over there. And then now comes as the coordinate, and you have to remember everything that appears on this slide. This is comprehensive knowledge for you guys to have for unit circle. So not only the position, not only the both of the measures of the angles, but also the exact value as a coordinate all over. Okay, this is the final destination for us to know from the unit circle. Any questions? Okay, so is that it? Okay, so just to remind you guys of this, in some of the practice problem is asking the sine and cosine and tangent ratio as well. So just remind you guys of this, and then with this unit circle, right? And if you would like to, and you can just, you know, download this notes from that page, and then you can just make print out of these slides, and then you can have it as your reference, right? And some of the practice problem that you have to do is you just remember how you can find the sine. Sine is always this, the vertical coordinates, and cosine is always this horizontal coordinate all over here. And tangent is just nothing but you use the sine value on top and cosine value on the bottom, right? So that's all. So this is everything that we need for 8.3.